So friends, here we have the question on a closed coil helical spring having different parameter is given. So first me explain what is closed coil helical spring. So let me consider one spring having number of terms like this. Okay, so here some parameter you have to understand here. So here the load will be applied in a either in tensile or in the compression direction. Okay, so wire having some diameter, so this will be whatever the wire diameter, that will be termed as small d, and the mean diameter, so mean diameter will be the total diameter of the coil, that we call as a mean diameter, that will be denoted as capital D. Okay, where small d is the diameter of the wire and cap D is the diameter of the total wire, sorry, diameter of the spring. And the radius, okay, if you want to know the radius of the spring, so this will be, okay, from here the center of the spring will be half of the diameter, that will be taken as the radius of the total spring. Okay, so these are the some parameters, so you need to calculate what are the stresses in the developed in the spring, or sometimes you have to calculate the deflection of the spring. Okay, so here some of the values which are mentioned in this question. So having a closed coil helical spring of 100 millimeter diameter, so that is the mean diameter. So mean diameter take as capital D, it is given as 100 millimeter, is made of 20 turns. It means the number of turns. Let us say small n is the number of turns. It is having 20. It means 1 turn, 2 turns. So number of turns are here. It is in 3 turns. So like that, it's having a 20 turns. Okay. So having 10 millimeter is the diameter of the steel rod. So that is small d. As I said, small d will be the wire diameter. This one. So that is 10 millimeter is the wire diameter. So and it carries an axial load, that is this one. It carries an axial. Okay, axial means along the axis, the spring along the axis, the load will be applied in a. So let us say that load will be W and it is given as 100 Newton. So you need to find the shear stress developed in the spring. So shear stress, that is tau, you have to calculate, and deflection is delta. So these two values you need to find out for a spring value. So as you know that the shear stress formula will be 16 W R by pi d square, sorry, pi d cube is a formula for the spring when it's under the tensile load, and where the deflection, so it is 64 W R cube and by G d power of 4. This is a formula for to calculate the deflection. Okay, so here 16 W is the load, axial load, where R is the radius. Okay, so radius of this R you have to calculate. It means R is equal to what? It is caps D by 2, where R is equal to D by 2. It means you are getting 50 here, 50 millimeter. Okay, hope you got it. So now let us substitute the value. 16 into W is 100 Newton and R is 50 again, by pi D value is 10 mm, power of 3. So if you substitute here, so let us make in the calculator. 16 into 100 into 50 by pi into 10 power of 3. So it is 25.46 value is 25.46, and definitely the unit of stress will be Newton per millimeter square, because all the values means whatever the diameter, stress, everything which you consider in millimeter. So you are getting the values of stress in Newton per millimeter square. That's all. Now you have to calculate the deflection. So 64, again W, that is 100, R value is 50 power of 3, and N is the number of terms, that is 20, by G is the modulus of rigidity, that value is given in the quotient here, 0.84 into 10 power of 5. 0.84 into 10 power of 5. So Newton per millimeter square it is given. So you no need to change any units there. And D is again 10 power of 4. Now you have to calculate this value. So got 19.04, where deflection it will be in millimeter. It is the value of deflection is nothing but the displacement or moment. So that will be measured in millimeter. So these two values you can find out using these two formula. Okay. Thank you. Hope you understand. Have a good day.